Boom, you're on. Okay, so let's just do a simple intro so you guys don't have your laptops with you. Okay, so let's go through some basics.
Mm-hmm.
Okay, so let's go through some basics how a computer even works.
Okay.
Okay, so let me get this thing out. It doesn't work as well as I'd like it to.
Just basically it's money up front. Money to Sully up front. Yeah.
Okay, are you ready?
Yeah, ready.
Yeah. Okay.
Just try to left, I down the right.
Okay.
Try to left, I down the right.
Yeah. Okay, here we go. So let's do a little drawings. Okay, so I think the first thing we'll have to probably learn is learn some basics of like basic computer ideas, and then we'll go into more of the programming stuff.
Yeah.
Okay.
Let's go with paint.
Yeah. Okay. So let's make sure this thing's working, and it is.
Mm-hmm.
Okay. Okay. So a computer consists of millions of pieces, but essentially it boils down to this. We have a CPU. Okay. We have an area called RAM, and we have the hard drive.
Mm-hmm.
Okay?
Mm-hmm.
And I'll go through what these are right now. Okay? CPU is, well, let's start with the simplest. What's a hard drive? Hard drive is where everything gets stored when your machine goes off. Okay? So, for example, right now, this is not saved. This document, this painting is not saved. If I were right now to unplug the battery, and I turn the computer on again, I would not have what I just wrote right now because it wasn't saved. When I go over here and I press save, right now what this means, I'm saving it to the hard drive. Okay, so I go say I save it to my desktop and I save it as, test. When I just press save, boom, it just saved it to the hard drive. That's how things have permanence. It stays around. Okay? What's RAM? One more time?
Random access.
She's good. So, see,
Memory.
didn't know you were a programmer, Michaela.
That's about all I know.
So RAM, who cares what it means in the definition? It just means memory. Now, what does memory mean in a computer? It doesn't mean like by human memory. It means what is working at the moment. What is working at the moment?
What program is?
So right now, I'm doing this. This is not saved to the hard disk. This thing I just did right now, right? I didn't save it, but it's in memory. Okay, so memory is what you're working on at the moment. Whatever's on right now. For example, I have a Google web browser open up in memory. I have some file folders in memory now. I have Excel open in memory. I have, this paint in memory. If I don't save it and I unplug the computer and it shuts off automatic, whatever it is, I would lose everything. You have to put memory to the hard disk if you want to save it. Okay?
This is memory. Okay.
That's memory.
So it's going to be on the hard drive.
What?
Later.
What'd you say?
When it goes on the hard drive, it's not memory anymore.
Yeah.
No, then it's saved even when it's off.
Whatever's being processed right now
Is in memory. Yeah. And the CPU, that would be the equivalent of the brain. That's what actually uses this and this to do its work.
Okay.
It's the brain.
It uses both of them.
Yeah. CPU is what processes all the information inside the RAM, inside that space memory. Okay? So just to give it an example. So a hard drive is where you store things. So if you were, for example, taking a lot of videos, and pictures, and you want to store it on your computer, and you go in a shop for a computer, well, you better make sure it's got a big hard drive. Because that's what you need. You need to store a lot of information. You don't need to work with that many images at one time. You're just storing a lot of information. But if you're using a software, some type of software like, say, Adobe has software that's very intensive. It uses a lot of memory because it's very complex. If you are making designs and pictures and graphics, or like games, people play very powerful games on computers. Those you need a RAM, right? You need a RAM for that because that's
the current memory. Yeah.
That's the current what's going on.
Yeah.
For example, most games don't need such a big hard drive, but while you're playing them, millions of things are going on. You can be flying in the airplane, there's stuff going on there. For a computer to do that and make that run, you need a lot of RAM. So that's why gamers, and when they're buying computers, they go and make sure they're buying it there's a lot of RAM. Mm-hmm. Okay? And the CPU, obviously, you want a good one. That's the brain, and that runs it.
Well, I'm not sure exactly what the CPU is.
CPU, I mean, obviously, we're not going to go into how this works, but CPU is the brain of the computer. This is what actually, when you type information on your computer, it'll take what you're typing, and it knows what to do, and goes into RAM and uses that area to get you the result.
But
It's the
there's
processor.
2 parts, and this makes sure it puts some things to RAM, puts some to memory. It's the one
Yeah.
It does all the
If you were talking about pictures.
Yeah.
So let's say you've got way too many pictures, but if you save them in an outside thing like
onto
that's the cloud, right?
if you save it on someone else's hard drive, that's all you're doing.
That's what you're doing.
Yeah.
So then you're taking it out of yours.
Right.
Okay.
So if you were to go, for example, there's a thing called Dropbox, right? What Dropbox basically is a hard drive, but it's not on your machine. It's on someone else's machine, some company. So you take your files and go, okay, you hold my pictures and all my files. And there's benefits and cons of doing that, but we're not going to go into that now. The point is that you have to recognize that when you're storing something, it's a hard drive. When you're using something, it's in memory, and what makes all this happen is a CPU.
Mm-hmm.
Now, obviously, there's more components of a computer, but this is the core of a computer. Now, when I mean computer, I don't mean this. I mean any device. This itself has a CPU, has RAM, has a hard drive. Any type of computing device, all iPhones, all Androids, all iPads, all tablets, laptops, computers, servers. And even now, you'll find teeny devices in house, appliances. They'll have this.
The question is, where in all this is the coffee?
Everywhere.
You have it here?
Coffee machines will have this too.
Really?
Yeah, many
Yes,
of
they are
advanced
computerized.
Advanced coffee machines with computers on it.
Computers, they have to have it.
So this is the basic. This right here is the core of any computing device. Okay, and it's very just this information. You can know already so much of what you need. If you find that your phone is slow, that means you have issues with your RAM. Remember, slow is at the moment what's going on. Right? My wife just had an issue where she tried to save a video and it said you're out of space. Well, that means her hard drive is out of space. She's got to do something with the hard drive.
The hard drive is storing. Okay.
Yeah.
Right? Yeah.
Okay.
Okay. The CPU is you just better buy a good one. When you buy any computing device, make sure you have a good CPU. Okay. Now, CPUs are made by good ones in Israel, Intel. Now, obviously, Intel's not completely in Israel, but Israel has a big part in the process of the CPUs. Okay. This is the general.
It's a processing unit, right?
Yeah, central processing unit.
Central processing unit.
Yeah, it's the brain.
Central.
Okay.
Okay, that's that. Now let's go to a new one.
It works like a human brain. I mean, you store things on your brain. You have the brain processes the information, and it has a random memory, which is what you're doing currently, right?
Yeah, so the word random memory is really a bad word. It doesn't really define anything. It's really just what's working at the moment. That's really the best way to think about it. Yeah, what you're doing at the moment.
Or in the
It's
past
all
5
being,
minutes.
it's being recorded anyways. You have to record it.
Or in the past 10 minutes, right?
What do you mean the past 10 minutes?
Whatever you went in the computer in the past 10 minutes, it stores there like a
It wouldn't be. It's until you save. Put it that way. Until you save. Everything's in memory until you save.
Yeah, because like when I am surfing the internet and I want to go back, it's still there. All the other.
So it's not really there. What's happening when you do that? I'm gonna show you exactly what's happening.
That's not the RAM.
That's not RAM.
That's the question on the RAM.
He's asking it on the internet. For example, if I go to here, say I go to Google.com, and then I go to a website called, I don't know, let's call it, Aishatora.com. Okay, so he's saying, okay, go there. If I go back, he's saying that's in memory.
That's the memory.
So it's not really. That's
RAM.
not a good example.
Okay.
It looks like memory, so and it has an appearance. What's really happening is, if you go over here, there's a history. Inside the history, it's storing where you're going, and it just goes to the last one you went to.
Oh, what is that?
So when you press it back,
Why is that not memory?
That's the RAM.
it's not memory. It's actually storing it to your hard drive.
But that's the RAM.
It's not memory. No.
No.
This is actually stored on your hard drive. So right now, yeah, we're looking at it in RAM, but it doesn't have to at the moment store it in
It's the hard drive.
the hard drive.
Yeah.
Now, when I click it, it takes it out of the hard drive and goes to that location.
Oh, so there is something that is in the hard drive. This is a hard drive. You're erasing from the hard drive.
Well, what I mean by hard drive, right now, obviously, when I'm looking at it, it must be in RAM, but it only does it when it needs it, right? For example, say I go over here, right, and I open this file.
That's obviously.
So right now, this what I'm looking at is in RAM, but it's not opening the actual file. When I click it, now it just went to the hard drive, pulled the file out of the hard drive, and shows it to me. And now we're in RAM. Okay? If I make a change and save it, back to the hard drive.
RAM is whatever is present at the moment.
Yes.
What is ever showing.
Yeah, showing and working at the moment.
It will work.
Sometimes it's actually invisible, but it's actually
I understand the history. The history is not RAM.
no, it's not RAM. It looks like RAM.
Processing now.
Oh,
Exactly.
that's right.
It's on the hard drive.
Hard drive is the.
It's actually stored on your disk. When you press back, what's happening is it's going to the disk, grabbing the last address you went to, and going to it in memory. But before I press back, all the history is in the hard drive. Okay? But you're right. It looks like memory.
Oh, when they have these years ago CD-ROM and CD-RAM, that RAM doesn't have to do with.
CD-ROM is another way to store information.
I don't know.
So it's another type of hard disk. A hard disk can be even where's my keys? I have information on this too. So if I want to, this is my hard disk as well. It's any place you're storing information that's staying, what they were called, permanence.
No.
So if I take this and put it in here now, when I save a document, it'll say, do you want to save it to this hard disk, this thumb drive? Okay? That's the basic gist. Okay, any questions on that?
No.
Perfect.
Anything in time?
So you say RAM is the what's going right now.
Yeah.
Okay, so when you show the history, that was actually the
Stored.
hard drive.
Well, it's on the hard drive. Anytime you're showing on the screen, it's obviously memory. But he's basically all your history is stored there
On the what?
on the hard drive. When you want to go back, when I go click over here, what's happening now when I press click is it's going to go to the hard disk, pull the last one I went
Like a
to.
document.
Yes, exactly.
Let's do the RAM. Okay, RAM is going down. Got it.
Okay, so that's that. No questions at all? Okay, so let's get this closed. Let's go back down to the painting. Okay, so a computer is obviously built on layers upon layers upon layers. I mean, computers people think is a new invention. It's actually been being invented for the past couple hundred years. It's been just slow steps, then leaps, then slow steps, then leaps. But that's why, I mean, it's really impossible to understand how computers work. It's just really impossible. And I feel bad for Moshe, because Moshe likes to understand everything. And you're not going to end.
Slowly.
I'm saying you're not. It's not going to end. I have books upon books. All these books over here on the computers, I haven't scratched the surface.
It's a language. It's a
How do you make it? Can't scratch the surface.
Huh?
You can make something by not know about it, I guess.
What do you mean?
You can make something by not.
100%. It's very easy to make something. That's the whole point of the computer, to make your life easier. But to understand how this is built, you really got to learn a lot of things. So we're not going to even discuss any of the foundations. You don't need to know it. As a developer and a programmer, you don't need to know it at all. But I'm just giving an introduction, therefore you're not in the complete lost. Okay, so basically, really low-level computer design. Okay, let's go to I'm just doing this for the sake of just so you understand some of the behind the scenes. Okay, imagine we have a tube like this. Okay, and then here's another tube, another tube, another tube. See, this is gate. Let's call this 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Okay, so we have 8 tubes. Okay, and say under these tubes is a place that things can fall into. Okay, so if I drop a ball over here, boom, it'll land over here. Okay, but now on the bottom of this tube is a door that can be open or closed. So if I drop a ball down and the ball is going down and it's closed, what will happen? It won't land in here, right? If I drop a ball down here and the gate is open, say the gate's like this now, boom, the ball will drop and you'll have a ball over here. If I drop this one and the gate's open, boom, it'll land and you'll have it over here. If this one's closed, the ball will not go to the end. Okay? So if we look at this picture, say these are all blocked. Okay? And then this one happens to be open, right? Okay? And this one stays blocked. So we have 8 spots for balls to fall through, and we have only a position over here and these 2. So this would be equaling, let's just use it as ones as yes. 0, 0, 0, 1, 1, 0. You are now looking at a byte of information.
A byte?
A byte. A byte is 8 bits. Yeah, now instead of balls, it's electricity flowing down, you know, on these teeny little tracks of electricity. And the gates are open or closed, the same thing. Okay, this is a byte of information. A computer only understands, believe it or not, this is crazy. A computer only understands zeros and ones. That is it.
Binomial.
What?
Which means go do something or don't do it, right? Negative and positive.
Yeah, and that's it. Everything you see, all these pictures and designs and Google and Gmail, everything I built on zeros and ones. It's truly mind-boggling.
Well, it all comes from, it's all in nature. It's like the duality of day and night, and what else is dual, cold and hot.
Yeah, and that's what I'm saying. It's an old system. For example, Morse code is one of the foundations of computers, believe it or not. The idea of open and closed. Morse code, what do they call it for the blind?
Braille.
Braille is another form of old computing ideas, of having ideas represented in open and closed, up and down. Okay, so what does this mean in anything? Let's do a simple example. Okay, say you're counting from 1 to 10. Okay, that's how do we do this?
So if that's a byte, what's a bait? No, there's something called bait?
No.
Byte and bit. A bit is one of them, a byte is 8.
Oh, a bit.
Kilobytes, no.
Kilobits and kilobytes, yes.
What's this?
That's 1,000 bytes, or 1,000.
What's this called, a byte?
This is a byte, and a byte has 8 bits.
No, kilobytes, no.
Now I'm going to move to the side so we can see a little more space over here for a second. Okay, so watch this. We're going to count to 10 in how we count to 10, which is called in decimal format, right?
Yeah, we're on a base 10. And
Base 10.
Base 2.
This is base 2.
Yeah.
Okay, so let's do that right now. Ready? So we have. Let's open a different screen to be a lot easier. Let's open one of these. Okay, so we have a new file here. Later on, we'll teach you how to use this cool system. But okay, so say we have. We're going to count to 1 to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, what happens when you go to 10? 1, 0, right?
2 digits.
Okay, so we in other words, we only really have in numbers. We only really have 9 or 10 if you want to count 0. Let's count 0 as well.
Yeah.
What
So we have only.
99?
Can you?
What about 99?
But all we have, you think about it, all we have are these 10 options.
Yeah.
Yeah.
And then we just play around with it, and then we go back again. So 10 would be like this, right?
Yeah. So it's 1
But
and
if you go
0.
do new symbol.
There's no new
Just
symbol.
playing around with the
digits,
symbols.
Right. So let's go like
It
this.
symbolizes the 10 Aseret that you wrote and the 10 Sefirot. You only have 10.
So now with the computers, and we're different. And you should know that. Well, let's leave it more simple for now. So we have 10, right?
Right.
And then we go like this. 11, 12, 13, etc.
Correct.
Right? Okay. Let's do now the same thing for binaries. Okay.
Binary?
Yeah.
That's for computers. It's just 0 and 1s. If we only have 0 and 1s, how would it look like? Some space over here so we have some more space. Okay. Okay. Okay, so 0, 0, right?
Right.
That's the same thing. Okay, you want to do 1, so let's do 0, 1. Okay. So, but now, what do you do for 2?
1, 0.
So, here we go. 1, 0. And what do you do for 3?
1, 1.
There you go.
What? I don't get why is 2 and 1 0?
Because all you have is the only options you have.
Ones and zeros.
So you have to add the most you could is 1.
That's right. That's 3.
Yeah.
Number 3.
The,
One,
com-
1 and 2. 1
no.
1, 0. Just like 1, 0 is 10.
The computer only understands
Oh, I
ones
see.
and zeros. She doesn't understand 3, 4, 5. You
You have to
understand?
start with 0 because that's the
Right.
that's the correct before.
So-
Yeah. So 0 is look over here. Look at the screen for a second. This is 0.
Yeah,
This would be 1.
but it's the next
Right.
afterwards.
Then up that you go to 1, 0.
Right, that's the only option you have.
Right. Then 1, 1. Now what will be the next one? What's 4?
0, 1, 0.
No, 0 before on the left side means nothing. So it wouldn't mean to add anything on the left side.
1, 0, 1.
You add a 0.
So imagine
Go back
the
to the
easiest way to
formula.
do that, if you're a human, because we're only humans, is imagine these are 9s. What would be the next number?
All we imagine are 9.
Because watch.
100. 100.
Here we go.
Right.
Confusing though.
If you imagine it's 9s, you get the right answer. 100.
Right, okay. So
Okay.
the next one will be 1,
How would I know if it's 9s?
Because just like 9s by us is when we flip, it helps our brain focus. When you flip to 9s, that's when you know you're going to the next
Confused now.
extra space.
When you flip the 9, you're going next thing.
You're going to add another number. You get 99, you get 100. 999, you go to 1,000.
After 9 will bring us the next thing.
Right.
So you think of
There's
9.
nowhere else you can go after
I didn't get
0,
the
1,
essence of
1.
nine,
Hit
so-
the 0, 1.
Now don't worry, this stuff you don't have to be a master at all for programming. I just want to give you the foundation
So
so
if
at
it
least you
adds
have an
everything else,
appreciation.
if it
Huh?
adds, so when you want to get to 4, you have to add a 0 to everything else.
So that
You have to go back the whole thing and put a 0.
okay, so let's go to the next one. What would be 5?
1, 1, 0.
1, 1, 0.
101?
Here we go.
101.
Yeah.
Yeah, order.
Right.
So what's the next one?
One,
Imagine they're 9s.
I understand why 101 is 4.
1, 1, 0.
I mean, 1 0 is 4.
Huh?
Yeah.
Why is 100 4? 9. Okay.
So let's look over here. We have 0. 0 is 0. That's the same thing. 1 is the same thing as 1. But now there's no 2, so we got to flip up to the next character.
0 1.
So 1 0,
1 0, right.
right? Then we have to go to 1 1.
Right.
Then we have no room left, so we got to go all the way up to here.
So you keep going that way.
Just like you do in over here. We had 9, and then we had to go to 10. We had to add an extra space.
You have to add extra space, but the Hebrew way.
No, just like I look.
At the beginning, there was no 0 in the
Okay,
last
no, okay,
first
okay.
letter.
This means nothing. I'm just doing this for the sake
No,
of
no, I
it.
understand. I understand.
This means nothing. I can take off the leading zeros. I'm just doing that so you can see it all in one line.
Oh, okay, okay.
Just like over here.
But why is it 100? Why is it?
Because after 11, you cannot use 2 or 3 or 4 or 5.
Just like over here,
Zeros
see?
and ones.
Okay.
I'm gonna take this off as well, so it doesn't confuse you.
That's the only
Because by 9s, you go back to the beginning
Right.
process.
So you see over here how we have over here 9, then jumps to 2, we have 10.
Go
Right.
back to 1 and now.
Okay. So what would be 7?
1, 1, 1?
No. 1, 1, 1.
Yeah.
Okay. Well,
And then 1,000.
No.
yeah.
Yeah. 1,000. It's right there. You
Oh.
cannot put 2s there.
What's 1,000? Oh, that's 10.
Oh, yeah,
That's
1,000.
10.
So remember, we don't when you're speaking bytes, you can't say 1,000. 1,000
Right.
is in our way because we use
So you have to
base 10.
say
Yeah, there's really no way to
One,
say
two.
it.
1, 1, 0, 0, 0.
Yeah,
What
this
is that? That's 10?
This would be 8.
That's 8. 5 is 111. Which one is the 111?
Look over here. I'm matching up over here. You see, all the way across. So 5 is 101. 6 is 111. Don't write them all down. Make sure you get what is happening here.
So what's the next one after 100?
It's 1001.
Here we go.
1001. 1.
Okay, so what would be 10?
It's digital.
One.
Yeah, 101.
No, 1010.
Okay. Okay.
011.
Yeah, you got it. So you got the pattern. That is
Write
bytes.
this down. I get
This
this.
is digit placing.
Yeah.
101. I'll have to look at it. Yes. So that is
Why did you put the specific order 1, 2, 3, 4, 5, 6, 7, like the first column that you have? You could have started on number 2, right? Or
No,
number
this
three?
is showing like equivalents. How would you express the
No.
number?
I'm not
10
talking about
decimal number
the
there?
first column you have is an ordering 1, 2, 3, 4, 5, all to number 19. Why
No,
did you choose
that's-
to
No,
start
no,
with
no,
number-
ignore that. Ignore
This is
that.
from the actual text editor. I'm using.
That's what I'm saying. You didn't choose 4 in order
No,
to
this
start
over
number
here,
two,
these
right?
numbers over here,
Ignore
Yeah.
ignore that. That's not even for
Okay,
me.
all right.
That every time I add an enter, it adds those.
Yeah.
It's just showing where we're on this
So
book I'm on.
after 1010,
So
the
1,
next
1,
one
1,
would be
1, 0, 1, 1.
yeah. Okay.
yeah 1011.
Yeah.
Yeah, and then 1, 1, 1, 1.
Okay, so what happens is over here, going back to our diagram, bytes are the core. Computers pass our information basically in bytes. Okay, so we have a set of 8. So over here, let's take this away for a second. Okay, so if we had this,
A byte is 8 digits? Doesn't it?
No.
a byte is 8
Oh,
bits.
yeah. Take this.
I spell bits.
BITS.
Bits and pieces.
Okay, so look back at the screen for a second. Okay, so say here is where our thing was. We had the balls are really electricity,
Right.
and this is where it's storing it. So say we have this is what happens in electricity. As soon as it flies down, the gate's blocked; it can't go through. Over here it goes through, and it opens the gate. So this would be the equivalent of 0, 0, 0, 0, 0, 1, 1, 0, which equals what?
110? No, 1, 0.
110.
1, 1, 0 equals what?
It's 6.
There you go.
Yeah, I haven't mastered all this damn chart. I was trying to write.
Don't master the chart at all. Understand the
I'm
logic.
not
of
trying to
it.
understand that.
Yeah.
I'm
But
trying
you go back to the screen.
think about the
So
9.
when you store, if I go into a text editor and I go like this, and it goes 6, and I press save, what's happening behind the screen is it's storing this inside the hard drive. And it's not 110, it's actually electricity gates. The
Okay.
gates are opened in a certain way to represent 1, 1, 0.
Oh, because you must have 8. Yeah, so you have to have all the other zeros.
Yeah, and this is
before.
obviously in a very simplistic way. Obviously, you know, when you're working with, this is just a core, basic idea of how
It's a language.
the computers understand what you're typing. Everything that you're typing equals a certain set of bits.
Mm-hmm.
Okay.
Okay, I'm trying
It's
to.
like a language. It's like a code.
Yeah.
It means that when you type number 6, the computer, the way
Understands
that the
that.
computer, for it to print number 6, it has to understand it as 1 zeros, 1 zeros, 1 zero. So
Yeah.
it goes back here, and this is where it goes like, like this. Has 0, 0, 0, 0, 0, 1, 1. And that was the code for 6 that you had, that the computer had.
That's 6.
Because somebody programmed it in there. That's what programming is. Somebody put this like he's
Well,
doing
no,
over there,
this is how you count. This is how computers count.
Yeah, but who created the byte? Whoever created the byte is already programming it for
No,
it to
no.
be like that, no?
No.
A byte
This
is a natural phenomenon. It's an electrical thing.
It's electricity is with gates. They have gates open or closed.
Yeah.
It's a physical
so
thing.
It's all electrical.
This is really a physical thing. This is not anything that's
yeah,
logical.
It's physical. It's physical.
This is a really physical thing. There's actually gates in your computer that are microscopic. You can have a teeny chip with billions of them.
Yeah.
And those are actually, when you turn your computer off and you save your documents, it actually stores the gates open in a certain way they represent 0, 0, 1, 1, 0,
Yeah,
0, 1,
yeah,
1.
yeah, yeah. So it's the electrical impulse itself.
Amazing.
So.
It's really a phenomenon. This is obviously a very simplistic sense, but this is very.
Yeah.
It gives you a general idea of what's going on the low level. What's good about this is that number one, it shows you that anything you're doing on a computer essentially is bytes. So you shouldn't get confused that, oh, this program is that program, this is that program, this is this computer, and that's that. End of the day, they all work the same thing behind the scenes. They're all dealing with bits and bytes. That's all it is. So, if you have a program and it doesn't seem to be working, dig one level lower, and you can find a common way of dealing with it.
Yeah.
I'm sorry, I didn't know what I wasn't.
Okay.
Figure this language out.
Maybe what to do is just cut this down
Together.
tonight. Just think on it, and you'll get it.
Okay, if
What
I
you
look
to
at
do
this and I
is-
look at this, I'll understand why
You'll
someone
copy it,
types
you'll
in
see.
6.
You'll cop this. You'll cop
Six
this.
is- Six is the-
You understand what it is? Like,
Yeah,
digit
because I
place.
did not.
6 is.
Yeah, this is a general idea of mathematics, base 2 mathematics.
Base 2, yeah. We're in a base 10.
We use base 10 because we have 10 fingers.
Yeah.
That's why we have base 10.
And that's a base.
If you were, say, I don't know, like,
You could go to a
Yeah,
base
drill
4 and
into it as a
another
big-
20.
right, if you were something like animal that's got like 2 fingers and each one you'd have a base, whatever it is.
This is really called digit placement, no? What is it called when we used to teach this?
The
to
children. Yeah, the
Digits.
unit. Each
The one
space
here is there's the
represents.
zero.
Now, so this is base 2, right?
Base 2, yeah.
Base 10 is decimal.
Yeah.
There's a thing called hexadecimal. Hexadecimal has, let me show you this.
16?
Yes, look at this. You have 1, 2, 3, 4,
Wow.
5, 6, 7, 8, 9, and what's 10?
10.
X, no?
You can't have 10 because it's base 16. So you
Right.
can't go to 10 because you're obviously doing decimal.
Explain what you're saying,
A,
decimal is 66.
B, C, D, E.
Oh, wow.
Okay, so this would be going over here.
Who uses that?
This is usually colors are written in this format.
Oh, you mean in computers?
Yeah. So if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, was that in there? 10, 11, 12, 13, 14, 15, 16. So you'd
The
have
notes in
E, F, G. So this is the reason, if you notice right now,
Write this down.
what's easy to notice about this?
Because it's 7 notes, it's 7 colors.
Notes.
Seven letters, 7 colors.
So it's cool, yeah, but what's interesting this, if it's 16, how many things are in here?
8.
There you go. This is why they did it. Because they pass around, information computer a lot of times passed around like that in sets of 2s like this, as an easy way that they're able to translate 16 positions with this. So if I were to say G, right, it automatically knows where things are stored. If you go over here, let me show you a quick example. Watch this. If I go to, if it ends soon as 8 o'clock, if I go over here, for example, and go to, watch this, say, hex, here we go, hex color. Okay, so if you notice this over here, this is a random website. I know where I'm going to right now. Okay, you see over here it says FF0000? That represents 1515. 0000 is red. If I go over here, okay, at CCFF99, this color, that would be 1212 15 151599. That's how they able to translate so many colors. If I have I work for a company and they say we have a certain color palette, we want all our documents to look like. They give me different colors. They're not gonna give me blue because it's a certain shade of blue. Well, how they tell me? This is our color palette, CCFF99GG, whatever it is. That's our color
It's
palette.
a shade. It's a color, yeah, it's all not colors.
No, I'm saying, I don't know, you lost.
Yeah, so we'll pause for now.
Was,
We'll pause for now.